Okay, hello everyone. My name is Mohammed Hourani. I am excited to introduce to you today Emma, which revolutionized the airport operations optimization. But let's start with some staggering statistics. So last summer, 1 out of 4 flights experienced delays in the US, while the total cost of these delays were 33 billion USD last year. In Europe, each 1 minute of flight delay costs around 100 euros. Now, I've been working in the aviation industry for over than a decade, and I witnessed the chaos and inefficiencies in the aviation industry caused by the siloed airport systems, the lack of proper coordination between the stakeholders, and also their usage of outdated means of communication. It's the mic. I think I will need the mic. It's very. I can shout, but is it now? Okay. So, so if you ask, for example, a ground handler and air traffic controller, what is the estimated time of arrival for a certain flight, most probably you will get different answers. So that's because of the siloed systems and the lack of proper collaboration. So at Emma, our mission is to improve the passenger journey via data and collaboration. So we start with integrating all of the data sources into one centralized location. Then we leverage this data using AI and machine learning to predict the key timestamps of the flight cycle and if there is any disruptions or delays on a certain flight. Also, we want to improve the communication and collaboration between stakeholders. So we built a messaging tool similar to Slack, but for airports. We also focus on configurability because each airport is different, and security because data permission is important, and of course, user experience. So as a result, Emma is a single version of the Truth platform that optimize airport operations, enhance decision making, and also reduce delays and inefficiencies. So the market potential is actually very significant. Now more than ever, people are eager to travel. We have seen this last summer. There was a lot of passengers eager to travel. Also, just keep in mind that more than 80% of the global population have never flown. Currently, we're focusing on small to medium-sized airports because these are easier to penetrate, but also we're reaching out to larger airports in the next couple of months. Since we started going to the market, we have signed 4 deals in a year. We also have more than 70 airports in pipeline, and it's growing rapidly. And our pricing model is quite unique in the aviation industry. So we price per aircraft movement. This is each arrival and departure. We are targeting 8 million aircraft movements in the next 5 years. This is around 10% of the global market. We have nicely positioned ourselves to disrupt the aviation industry. We focus mainly on innovation, also configurability and agility, and also affordability for airports and airlines. Our team is a combination of aviation veterans like Jean-Luc here and young talented engineers. Me, myself, I've been working in airports for over than 12 years. My co-founder Wissam has a successful track record in startups and entrepreneurship in Silicon Valley and also Middle East. So currently we're raising 4 million in our pre-series A, which will help us in expanding to new markets and also growing our product portfolio. Thank you very much for listening and for being here. Thank you.
Great, thank you, Emma. And now we are going to welcome on stage Silfaro.
Ouais, ouais, sur le menton. So, hello everyone. I am Tom Bernat, the co-founder and COO of Silfire, a French startup developing world's first electric plasma-based jet engines. The problems we want to solve are the following. Aviation currently represents between 3 and 4.9% of worldwide greenhouse gas emissions, and this could grow to 20% by 2050 if we don't act now. The other problem we want to solve is the current solution for electric aircraft are quite slow as they are using propellers. So we want to offer clean and fast air transportation systems. For that, our solution is to electrify jet engines. So in jet engines, the only energy source comes from the fuel that's burned in the combustion chamber. The goal of this process is to heat the air and then expand it and generate thrust. And we want to do the exact same thing by heating the air electrically, by generating an electric arc that will be blown by the air and then ionize the gas to create a plasma. So basically, electrical heating of the air. The main advantage, as I said, is the speed. We can target similar speed as a current jet engine and with very high specific power. Our competition on the electric propulsion side is quite limited in speed. The current record is 623 kilometers per hour. In our case, we can electrify any type of jet engine. So we have application in a lot of domains, the civilian market for business aviation, for example, and space and defense applications as well for super and hypersonic vehicles. The markets we're targeting, according to Markets and Markets, is of 92 billions, and it should only grow by the time the energy storage technologies are improving, because of course we rely on electricity, so we need to store it on board, and that's what limiting our technologies application right now. We target commercialization of our engines by 2030. It's a very long development cycle because of the certification process and the complexity of the subject we are targeting. We will provide most likely engine sales and the after-sales services regarding maintenance, overhaul, and repairs of parts. Currently, we are working on our first proof of concept, a 90 kilowatts turbojet engine that was designed in-house, some batteries. We spent the 2002 year working on the numerical conception, numerical design, and now we spent the 6 months of this year working on the manufacturing, and we are currently testing it. The full engine testing is expected for the end of this summer, at the end of the month of August. Afterwards, we will focus on the development of a large-scale demonstrator of our MVP that will be a multi-megawatts class of power and engine. Regarding our team, we are a team of engineers and scientists, quite young for now, but we are preparing a fundraising to expand our team, mostly with seniors that has expertise in a lot of fields necessary to develop that kind of engine. Even though we are young, we are advised by a lot of mentors that come from several programs. For example, the Blast from Starburst that we thank for being here, the Sustainable Aero Lab in Germany, and also the 3D Experience Lab from Dassault Systèmes. We have also a lot of partners. I mentioned Starburst. We are also helped financially by Airbus via the structure Airbus development, the ONERA as well, the European Space Agency, with which we signed a first contract to study space application of our technology, and more coming later. So thank you for listening, and you can meet us starting from tomorrow in Hall 2B in booth D80. Goodbye.
Thank you, Silfire. Very nice. So then we are going to welcome EC. Are you? AVD? EC company. Oh, you are there. Okay. Right. There is a huge change, just a little change. So I'm going to display. Welcome on stage.
Thank you. It's EC compliance. Okay. Well, good afternoon, everybody. EC compliance, I'm Mark Jarnowiecki. First of all, I'm going to talk about export control. So export control is a set of rules, a set of regulations that states implement in order to fight against the proliferation of weapons and dual-use technologies. So all kind of sensitive technologies used by aeronautics, space aircraft, and whatever that is in the area of aeronautics may be sensitive. There are plenty of regulations, there are numerous. These regulations are either national, at national level, but also at European level. And of course, US regulations are very impacting for all of us because we all buy plenty of technology coming from the US and we have to cope with their regulations. So if I summarize in a few words, what is export control? The control of a transaction or of a flow is you have to check, first of all, what is the good and how it's, under which classification does it fall, an export control classification. Then the country of destination is the second parameter I need to control. And the third one is the entity or the person of the end user. So if you manage these three parameters, you're able to give an export control advice or recommendation. So what happens if you don't comply with the rules? Well, first of all, you have huge fines, and they go by million. Then you can even go up to prison, because if you intentionally break the rules or you commit a violation, an export control violation, you can end up, of course, in prison. You can lose your export privileges, such as licenses, authorizations, but some markets may be closed also. Of course, there's a consequence on your contracts. If you breach a contract, you have to pay penalties to your customers. But the worst thing is the reputational damage. If you're not a real professional, an export control professional, your customer won't find you're a reliable partner. So you have to really be careful with your capacity or the way you manage export control. How can we mitigate this risk inside organization, companies, exporters? Well, it's a 5-step approach. You have to have in mind that if you have to build your compliance and make it simple, it's a sequence of 5 steps. If you follow the 5 steps, well, you can ship in full compliance. That means first step, classification. Classification is just like your codes, your customs codes, but this is specifically export control. You have to determine the classification. The next step is exportability. I match a classification with a destination, and then I can have a recommendation, either a green light, an orange light, I might need an authorization, a red light, it's a no-go because it's an embargoed country, for example. Once I've gone through this second step, the third one will be the screening. I have to screen entities, individuals on blacklists. You've all heard about the Russian oligarchs, Prigozhin, Putin, whatever, that are on blacklists, but also companies are on blacklists, like Huawei or other Chinese companies, even European companies may be on blacklists. Once you've gone through this third step, then you can say, I need an authorization. Do I have this authorization? I can manage my licenses and my authorization to export. And the last step, analytics, is where I'm going to store all the information for each of my flows in order to have all the information available, well documented, in order to give the information in the middle of an audit when asked, or just to my authorities when they need reports. But sometimes in export control, it may happen 5 years after the event. So you need to pick this information, to store it, and be able to give it in real time whenever needed. So this is how we can answer, anyway, we can face and mitigate the export control risk following the 5 steps of compliance. It's like a standard. What else do we do? Well, of course, we accompany our customers and companies needing export control solutions, not only with the software, but also with training, with auditing services, consulting services, and all kinds of services in order to help them to run or drive or pilot this, monitor this export control process inside their company. Thank you very much.
Thank you, EC Compliance. Now we are going to welcome on stage productive machines. You are there.
So this one is. Good afternoon, everyone. I am Dr. Erdem Öztürk. I am the founder and CEO of Productive Machines. Productive Machines is a spin-out company from Advanced Manufacturing Research Center from University of Sheffield. And we had the machining industry reach the best part faster and first time using our digital twin. We say work depends on milling machines. You might have seen a lot of aerospace components today, and many aerospace components use milling processes in the factory. One typical example is the bladed discs in jet engines. The way to produce this part has several steps, starting with the CAD design. So you create a CAM process, and then you post-process the CAM file output and send it to the machine. But the problem starts with when the process starts in the machines, because during the CAM process planning, physics of the process is not included. It's all based on geometry. What we do is we simulate the physics of the process to identify problems related to the cutting forces or vibrations, and we mitigate those problems by changing the process parameters. So rather than doing the iterations on the machine tools and spending time, effort, and then causing waste, we minimize the waste in the industry. And we basically decrease the resources consumption, such as materials, engineering time, and also energy and CO2 emissions, which is becoming very important. So what we do is we get a CAM file into our platform, and we provide a CAM file out, which doesn't require any training for the engineers. So we are not selling a software, we are selling a service which gives a solution to the clients, which are the machine tool companies. What we change is we change the spindle speed, which is the rotational speed of the milling tool, and how fast it moves translationally on the part. So our unique selling points is we have a unique digital twin solution that can identify the vibration problems along the whole tool path. So this is, for example, the stability map solution we have. X-axis is the time, y-axis is the spindle speed, and basically we can find the best spindle speeds on the stability map so that the client is confident that there will not be chatter vibration problems. And also it's a fully automated toolpath optimization solution, which is coming in December. It's not fully 100% automated yet, but it's coming by the end of December in 6 months. The team is 12 people at the moment. In fact, we had two people starting this week, so we are 14 now. But half of the team has PhDs in the machining dynamics area, which is the topic related to solving vibration problems in machining. And some information about the market. Machining industry is a $400 billion industry, and there are about 1.5 million milling machines in the world. And there are also like turning machines, which is under 1.5 million. So the potential impact is huge. And 25% of these machines are in Europe. And we are already working with clients in Germany, Denmark, and UK. And we work also with partners. So we are not doing direct sales. We want to work with already established businesses, such as machine tool companies. There are a lot of them here, so we are talking to them now. Cutting tool OEMs, machine sensor OEMs, and also CAD/CAM suppliers such as Siemens, CATIA. We would like to work with them. And the top market, of course, we started with aerospace. We work with high value components, but also we had to diverge to different industries such as automotive, medical, and constructions, because aerospace is great, but it's very slow. Sales cycle is very slow, so we had to go to other markets. As I just mentioned, to reiterate again, the current solution is not fully automated, I will say 80% automated, but by the end of the year, we will have a fully automated solution. So our aim is to give a client a response in 15 minutes, which will be less than the coffee break. So they upload a CAM file in our servers, and then in 15 minutes, they will get the optimized file back. Thank you for your listening to me, and this is our details. Productivemachines.co.uk is the website. You can reach us. Thank you very much. We also in the aerospace accelerated zone in F139 if you want to have a further chat. Thank you very much.
Thank you, Productive Machine. And the last one to pitch for today is Pelico. I welcome you on stage.
Thank you so much. How does that work? Just one button. Hi, everyone. I'm Tariq, founder and CEO of Pedico, and I'm super excited to be here. So before we talk about Pedico, currently, right now, manufacturing has become more complex than ever. So the good news is that the aerospace industry is facing a very steep ramp up with air traffic increasing year on year, with the MRO activities increasing. But there is one big challenge, which is supply chain. And supply chain disruptions are costing a lot of money currently to the main aerospace suppliers. There was a recent study that estimated the annual lost revenue being up to 160 million when we average it to the top global supply chain players. So when facing a steep ramp up and having supply chain disruptions, like all this complexity basically trickles down to the shop floor in the factory to people on the ground. And what ends up happening is that the weekly planning that is super optimized is not efficient. It's not feasible anymore because when you start in the morning, Tuesday at 7 a.m., at 7:15, the planning is not up to date anymore because you learn about late supplier delivery, some quality issue that happened, some demand change from the customer, a machine that is not available, etc. And when we put ourselves in the shoes of a production controller, for example, on the ground, ensure of anticipating the bottlenecks and executing the plan, this person has to deal with a lot of shifting variables. The person has to monitor, for example, 150 work orders, each one with start dates, end dates. It may have some subcontracted operations, feed in some customer orders. Some of them are firm, some contracted, some quality issues that need to be coordinated with engineering, some part shortages that need to be coordinated with supply chain teams. And in this context, basically, where all these variables keep moving all the time, the operational context changes faster than teams' ability to plan and react to it. So the feedback that is given to us by supply chain teams is we've put in place our managerial routines, we have those alignment meetings, we do rigorous analysis of our data, but the next day, everything we do just expires. And it's always blind spots and those disruptions that are totally jeopardizing performance. And the need that is expressed is having this real-time monitoring of bottlenecks and more agility on the ground to be able to solve issues. So this is where Pedico comes in. So Pedico acts as this intelligent layer that sits on top of the system that basically gathers all the data wherever it exists. And it basically provides this intelligent assistance to supply chain teams on the ground to enable them to, one, monitor bottlenecks in real time, but two, it helps them better react to them with recommended actions, the ability to simulate new plans, but also to collaborate throughout the whole value chain with a common language. Today, Pedico is leveraged by multiple leading players in aerospace, but in other industries as well. It's currently leveraged by Raytheon, by Safran, by Daher, but also in the luxury space, for example, with Cartier, ArcelorMittal, Daikin. The results are concrete. There is this testimony from this person working in a Cousins aerostructure plant saying like that Pedico helped them avoid 50 line stop in less than 2 months by putting in place Pedico. Safran managed to reduce part shortage by over 70% in 6 weeks after deploying Pedico. It's very low touch, very easy to deploy, and brings a lot of value to the teams on the ground. And that's it for me. Thank you so much.